Okay, so we are now going to discuss hydrocarbons, especially alkanes pa rin. This is the continuation of our class last time. So we were able to cover the basic concept about alkane, especially the nomenclature, which is very important. And then now we will proceed with the next part for the alkanes. Okay. So now, marunong na tayo mag-name ng alkane, malaman yung parent chain, substituent. Now we will proceed with this thing called isomerism. Okay. So, what is an isomer? So, technically speaking, when we say isomer, we are referring to compounds with the same chemical formula, but they differ in terms of the connectivity. Okay? So, iba-iba yung mga dinudugtungan nilang mga atom or pwede naman, iba-iba yung 3D positions nila. So, those are isomers. Okay? So, sa lecture, madidiscuss yung ano pang, yung isa pang uri ng isomer, which is the um, stereoisomer sa lecture na yon, pero sa lab discuss lang natin yung constitutional isomer. So when you say constitutional isomer, ito yung ano, iisa yung formula nila pero yung connectivity ng atoms magkakaiba. So let's take this molecules for example. So kunin natin yung butane and the 2-methyl propane. Okay, so we have butane, ito yon. And you have the 2-methyl propane. If you determine their formula, parehas silang C4H10. Okay? Apat na carbon. Apat. Tapos ilang hydrogens? Dito, tatlo hydrogens. Dito, dalawa. Dito, dalawa. Dito, tatlo. So that's 5 plus 5, 10. Okay, so C4H10 yan. Ito naman, C4H10 din yan. Apat na carbon, tatlong hydrogen, tatlong hydrogen, tatlong hydrogen, isang hydrogen. So, 10. Okay. So, that means, iisa formula nila. So, ibig sabihin, isomer sila, right? But, the specific term that we should use is not just isomer. Rather, it should be stereoisomer. Okay? Sorry. Mali. It should be constitutional isomer. So, yun yung tamang term to describe the butane and the 2-methyl propane. They are constitutional isomer. So, ano lang ba nangyari? So, basically, itong methyl group mo dito, itong carbon na to, lipat mo lang dun sa second carbon. Pag nilipat mo yan, it will look like this. Okay? Same thing with this one. What's this? 1, 2, 3, 4, 5, 6. Okay, so this is hexane. So, kapag itong carbon na yan, lipat mo yan dito sa second carbon, it will look like this. So, this is 2-methyl, 1, 2, 3, 4, 5, pentane. Baka isipin mo, ay, magkaiba yan, sir. No? Hindi, magkaiba sila technically. Because they are constitutional isomers of one another. Meaning, yung carbon nila, ni-rearrange mo lang. Okay? So, what else can we do about hexane? Kunwari, ito, ay, gusto ko, lipat ko yan dito. Pwede rin yan. So, you will have a different molecule. This will be 2,3-dimethyl butane. Ayan. Ito, lipat ko doon. Pwede ba yan? Pwede rin. No? Lipat mo doon. Okay. Ayan. So, that will be 2,2-dimethyl butane. Okay. So, yun yung ating mga constitutional isomer. So, just basically, ilipat-lipat mo lang yung position ng inyong carbons. As long as they will have the same formula. Kapag hindi same yung formula, hindi na yan constitutional isomer. Okay? So, yun lang. So, basahin natin to. Apparently, for your hydrocarbon, as the number of carbon atoms increases, the number of constitutional isomers that can be created also increases. So, ayan, no? So, ito yung ating hexane, C6H14. Ilan ba yung nagawa natin dito? So, 1, 2, 3, 4. Oh, meron pang isa. Ito yung isa. Ayan, 3-methyl pentane. So, these are the five, diba? Ayan, so these are the five constitutional isomers I can make from hexane. So, 1, 2, 3, 4, 5. So, yan yung 5 constitutional isomer. So, bakit kaya dumadami yung possibility ng constitutional isomer? Okay, as the carbon chain length increases in length. Malamang kasi you have many options. You have the variety of choices na pwede mo ilagay si carbon. Okay? So this is also the reason why there are so much organic compounds around us. So basically, sa nature, yung nangyayari lang dyan, minsan nga, constitutional isomerism lang yan eh. Okay? So yun, kaya ang daming mga compounds sa paligid natin. Okay? So that makes organic chem really diverse. Okay? Also, sometimes, when identifying constitutional isomerism, hindi siya obvious at all. Okay? So, paano mo malalaman if your constitutional isomers are indeed different, no? Kasi for example, so these are the constitutional isomers of hexane na drinowing ko. Sabi dito, ito daw at ito, same lang sila. Same ba sila? Oo, same daw eh. Sabi ng libro eh. Paano mo malalaman kung same sila? Ang pwede mo gawin is i-name mo sila. Eh, yun talaga yung pwede mo gawin. You can just name them or just think in a 3 dimension. Pwede mo ito i-rotate pataas. So it will look like this. The bond will look like that. Okay? Pwede mo siya i-flip pataas eh. Okay? So, ganun lang. So, in order for you not to be deceived, ang una mong gagawin is to double check the name, double check the formula, of course. If they are same formula, double check mo yung name. If iba-iba yung name, pero same yung formula, then constitutional isomer yan. Okay? And if you can work on your 3D or spatial reasoning, then you can imagine them, you can imagine the bonds as something that can be rotated na. So yun. So whatever fits your mind, go for it. Pero ako, I will just suggest you to go for the name, no. Kailangan masterin niyo yung naming ng organic compound. Kasi kapag alam mo na yung name niya, then ayun, dun yung mas madaling way to identify whether those are constitutional isomers or same lang pero ni-rotate lang yung molecule. Okay? So for example, here, ito yung molecule kanina. So, if you rotate this bond here, rotate mo yun by 180 degrees, then, ayan, magbabago itsura niya. However, same pa rin yung name niya. Okay, so they are the same. Okay, so that's how will you be able to identify whether they are different or same lang sila. Okay, so let's try this one. Okay, so sabi dito, identify daw natin siya if the two compounds are constitutional isomers or whether they are simply different drawings of the same compound. So, anong gagawin mo dyan? Ganito lang, basically, identify mo yung name. Okay, so ganun lang, identify the name. Okay, so I will do that, no? Mag-nomenclature ako. So, I will look for the parent chain. Okay, I will use a highlighter. So, this is the parent chain. Okay, for this one, I think this is the parent chain. Sorry. Should not be that one. It should be this one. And so that is the parent chain for that one, and for this one, yun yung parent chain niya. Okay? So, bilangin natin yung carbon na yan. Okay, so sa isip ko na lang binila ngayon, pero pakita natin. So this will be 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is no name. While this one is 1, 2, 3, 4, 5, 6, 7, 8, 9. So still no name pa rin. Okay, and then we can work on with the substituent. Numbering tayo. 1, 2, 3, 4, 5, 6, 7. Okay. So the name of this molecule will be 3-ethyl 2, diethyl pala yun. So this will be 3, 4 diethyl 2, 7 dimethyl no name. Okay, so yun yung name niya. Okay, so 3, 4 diethyl 2, 7 dimethyl no name. So yun yung name niya. Dito, gawin din natin yun. So counting, start ako dito. So 1, 2. Ayan. So it appears na same lang din sila ng name. Okay? So that's 3, 4 diethyl 2, 7 dimethyl. Okay? So same lang sila ng name. So again, kapag same ng name, ibig sabihin same compound lang sila. Okay? So do not be confused. Hindi porket magkaiba drawing, ibig sabihin different na. So I highly suggest you to practice the nomenclature for molecules like this. Okay? So in the next slide, we have several things na pwede nyo pag-practicean. Okay, so I need you to identify whether they are the same or different compounds. Okay? So yun lang. Pero bigyan ko na kayo ng clue. Tapos kayo na bahala mag-imagine bakit kaya naging ganun. So ito same compound yan. Okay? Ang B ay same compound din. Ang C ay same compound. Diba? Hindi obvious, diba? Ang gulo ng molecule. Pero same lang yan. And then, yung D, ito yung isomers. Constitutional isomer. Okay? So, yan. So again, do not be deceived by the mere drawing. Hindi porket mukhang kaiba ay magkaiba sila. Sometimes, yung bond niro-rotate lang in order to create confusion. Okay? Just to identify kung binabasa niyo ba talaga yung mga nomenclature niya. Okay? So again, in order for you to identify kung same lang yan or constitutional isomer yan, first thing you'll need to do is to name them. Always name them. Okay? So yan yung answers. Then I want you to ponder bakit sila constitutional isomer, bakit yung iba ay same compound. Okay? So let's try this another exercise. Nasagot na natin to kanina eh. Nasagot na natin to. So we need to draw the 5 constitutional isomers of C6H14. So basically, nasagot ko na siya earlier. Ito yun. So you have the hexane, the 2-methylpentane, 3-methylpentane, the 2,2-dimethylbutane, and the 2,3-dimethylbutane. Okay? So again, ano uli difference ng constitutional isomer sa same compound lang. Okay. So pag sinabi constitutional isomer, yung formula parehas pero yung connectivity magkakaiba. Kapag same compound yan, pwede yung drawing medyo magulo lang pero yung nomenclature same lang. Okay? So hindi porket mukhang magkaiba yung drawing same constitutional isomer agad. No. Okay? You always have to double check the nomenclature. So use this as a practice, especially this previous slide. So use that as a practice in order for you to identify the correct name of the hydrocarbons shown there. Okay. So now let's proceed with the next part, which is about the sources of alkanes. So primarily source ng ating alkane ay yung mga patay na dinosaur. So yeah, literally dead dinosaur. So yun naman yung source of oil, di ba? So those living creatures that are buried deep down the oceans, no? Deep down in the crust, yun, they turned into oil. And apparently, yung oil na yon that can be extracted, no? Especially natural gas na nandun. So that can be drilled, or sometimes ginagawa dyan is fracking. Okay? So yung fracking, that is something like yung nasa lupa ka. Oil drill naman yung nasa dagat ka. Okay. So anyway, so these are the primary sources of our alkane. Commonly sa ating alkane, they come from natural gas and almost all of it ay methane. Bakit kaya methane? No? Kasi sabi ko, these are decaying matter, and usually decaying matter, with the help of the bacteria, dumadami yung methane doon. Okay? So majority of the natural gas ay methane, followed by some percentage of ethane and other um, hydrocarbons with greater length. Okay? O ito naman sa oil naman, yung oil, um, yung crudo na nakukuha sa ilalim ng dagat. So that is a liquid mixture. So katulad ng mixture discussion natin, any mixtures can be separated, no? Ibig sabihin, pwede sila pag-iwa-hiwalayin. So, in separating our petroleum, no, in order to get the hydrocarbons from there, they use what's called the fractional distillation. So, in a fractional distillation, basically, may mga fractions lang tong column na yan. Okay? So, depende dun sa mga fractions na yan, dun makokolekta yung mga molecules na gusto mo makuha. So, as we know, the intermolecular forces of attraction play important role for this one. Okay? So, ibig sabihin, kapag masyadong mataas ang intermolecular forces ng iyong hydrocarbon, for example, malaking hydrocarbon chain yan, ibig sabihin, mas matagal siya magbo-boil, while shorter hydrocarbon chains will boil faster because of lower intermolecular forces of attraction. So, sila yung magbo-boil agad, no? Pero yung iba, matagal bago mag-boil. And apparently, yung ating petroleum, no, na nakukuha sa dagat, it can be used in several materials, no? Yung gases, ayan. Saan ginagamit yan? Diba? Kapag nagsangyup kayo, sometimes they use butane torch. And apparently, butane can be obtained from petroleum. It is in the highest column kasi mababa lang yung boiling point niyan. Down here, you have your gasoline, mga gasolina sa sasakyan, including octane. Yan. Followed by kerosene. Ito yung mga ginagamit sa mga SUV naman. And mga mga truck. Ayan. Followed by your fuel oil. Ito yung mga mantika sa ating oil, sa ating sasakyan. And then followed by lubricating oil and the residue which are used as asphalt. No? So ibig sabihin yung drilling na ginagawa dun sa mga nasa dagat na nakikita nyo, it is not just about petroleum. Rather, you can also extract other hydrocarbons serving different functions. Okay? Pero ang primary na nakukuha natin doon is, as you know, is gasolina and kerosene. Okay? So now, ito naman, let's talk about the cycloalkanes. Okay? Pag sinabi nating cycloalkanes, these are alkanes. Okay? These are alkanes na naka-ring. Okay? So, kunwari, butane, no? Di ba ang butane, 4 na carbon na magkakahiwalay yan. Pwede mo sila pagdugtungin, no? Pag pinagdugtong mo yan, it will form a square. Right? So, ang pentane, ganun din. Yung 5 carbon chain na yon, pwede mo yung pagdugtungin. Okay? Pwede mo sila ipa-circle. And yung ating cyclohexane, it came from your hexane. Idugtong mo lang ito doon. You will form your cyclohexane. Okay? So, yung ating cycloalkanes, yung ring sizes nila, they vary from 3 carbons up to 30 carbons. However, the most predominant form of our cycloalkane are those of 5 and 6 carbon chain lang. Okay? So usually, ang nakikita lang talaga in nature is the cyclopentane and the cyclohexane. Okay? So yun. Ang tanong, bakit? Yan yung important eh. Tanong, bakit kaya yun lang yung madalas makita? Why are the others non-existent? Especially yung ating cyclopropane. No? Although it exists, no? Nag-exist yan, pero it's not really abundant. Bakit? Mas prefer nila ito kaysa sa mga to. Later discuss natin. Okay? So later. Anyway, for now, let's visit this idea called the conformation of butane. When we say conformation, we are referring to the arrangement of your atoms in your molecule caused by the rotation of the chemical bonds. No? Remember, kapag single bond, ibig sabihin, tetrahedral. Ibig sabihin, naka-3 yung ating molecule. And at the same time, since isa lang naman yung bond natin, that means that we can rotate the bond. Okay? So, looking at cyclobutane, so the normal structure for cyclobutane looks like this one. Let me pause the screen sharing para makita nyo. Okay, so this is our cyclobutane, right? So this is the cyclobutane. As you draw it, naka-zigzag siya because apparently naka-zigzag talaga siya. And the reason bakit yan zigzag is due to the tetrahedral geometry of the carbon as they are sp3 hybridized. Okay? sp3 to, so that's tetrahedral. Ayan, nakita niyo yung tetrahedral, right? This is also tetrahedral. This is also tetrahedral and another tetrahedral. So all of the atoms here are tetrahedral. Okay? So, gaya nga ng sinabi ko, the tetrahedral atoms can be rotated. Okay? Yung mga naka-single bond lang, you can rotate that. Okay? So, look at this, naro-rotate ko siya. Okay? You can rotate single bonds kasi. Okay? So, this is just one of the conformation of our butane. Conformation, ibig sabihin, yung rotation. So, yan. So, this is the normal conformation of butane wherein naka-zigzag lang yung ating carbon. Another conformation is that when we flip this carbon, flip natin to by 120 degrees. So, when I flip this by 120 degrees, it will look like this. Okay? Pakita ko ulit. Kanina, ganito lang siya. But when I flip it by 120 degrees, naging ganito na siya. Okay? So, kanina ganyan lang, normal zigzag. Ngayon, napunta na siya dito sa side ko. Okay? And then, you can also rotate this again by 60 degrees. May ganito na siya. Okay? So, yun yung pinapakita dito sa ating PowerPoint. Okay, let me reshare again the PowerPoint para makita nyo. Okay, so yan yung ating mga conformation for butane. Basically, you will just need to rotate the bonds kasi single bond naman yan. It can be rotated. So, you can rotate it by 120 followed by another 60. Okay, and then you have your 3 conformations for the butane. Ngayon, ano naman yung effect niyan? So apparently, by rotating your bond, merong tinatawag tayong mga um, repulsion. Meron tayong mga interactions. Okay? So, ipakita ko uli yung aking model. So, let's consider the normal chain of our butane. So, ang gagawin natin, we need to look at this line. We need to look at this line. Okay? So, itatapat ko to sa inyo at ano yung napapansin nyo. So, tatanggalin ko yung mga hydrogen dito sa dulo. Okay, let me remove them para hindi kayo ma-confuse. Okay, so ayan. So again, this is just the butane. I removed the hydrogens at the end para mas clear. Itong hydrogens dito, tinabi ko siya. So again, we will look at this angle. And if I point it to you, this is how it should look like. What can you say about this image na nakikita nyo? Ang nakikita natin is that the atoms do not overlap on top of each other. Hindi sila nagpapatong-patong. That's why this is the best conformation for the butane. Bakit siya best conformation? Best siya kasi yung ating mga atoms, hindi sila nagpapatong-patong. Okay? So as you can see, ito nakapataas, ito nakapababa, ito nasa taas, ito nasa baba. So if hindi nagpapatong-patong yung ating groups, we call it the anti-conformation. Anti. Okay? So this is the anti-conformation. Okay, now let me show you yung PowerPoint natin dyan. So this one is the anti-conformation. Okay, ayan yung na pinapakita ko dito, di ba? Okay, so these are the hydrogens. They are not overlapping each other. And the carbon groups do not touch each other. Okay, so that is your anti-configuration. Now, let us try to rotate this by 120 degrees. So let us try to rotate this by 120 degrees. Itong nasa likod na lang. 120 degrees. What can you say about this? Ano masasabi nyo? Yes, they are not overlapping. Pero, may nanonotice kayo. Ano yan? Kanina, teka lang. Kanina, ito yan, di ba? Remember, the carbons are big atoms. Malalaking atoms yung carbon. So, it is best if they are in the anti-conformation. Magkahiwala yung carbon atom. Kasi malalaking atom yan eh. Malalaking atom yan. So, maganda na magkahiwalay talaga sila. So, that's why we said the anti-conformation is the best conformation for the butane. However, when I rotate it by 120 degrees, ano nangyari? So, ang nangyari is that yung carbons mo, naging magkalapit. Naging neighbors na sila. Ito, pati ito. They are near to each other. So, ano tawag nun? If they are near to each other, tawag dyan ay gauche. Okay, gauche ang basa dyan. So, yan. The carbons are near to each other. Tawag doon ay gauche. Again, pag magkahiwalay, nasa opposite end sila, you call it the anti-conformation. This is the anti. Magkabilang dulo sila. Pero when they are near to each other, tawag dyan ay gauche conformation. So what's the implication? If you have a gauche conformation, then the bulky groups of carbon will repel each other, causing this molecule to be kind of unstable. Okay, so this conformation of butane is kind of unstable due to the proximity of your carbon groups, no? Magkadikit kasi, so magre-repel sila. So again, kapag gauche, medyo unstable yan. Okay? So let me show you how it looks like in the PowerPoint. So in the PowerPoint, it is represented by this thing here. So that is the gauche conformation, wherein the carbon groups are kind of near to one another. They are at 60-degree angle. So ano susunod? Next na pwede natin gawin is to overlap the carbon. Ano tawag doon kapag in-overlap mo sila? Sabi dyan sa PowerPoint, kapag in-overlap mo yung carbons mo, tawag doon ay eclipse. Nandito ba yan? Ay, hindi pinakita. I think I forgot to. Anyway, so yan, ang tawag doon ay eclipse. So wala akong picture dito. So sorry, di ko nakopya. Ayan. So pag pinagpatong mo na yung dalawang carbon groups mo doon, you call it eclipse. No? So, pag eclipse yon, yung carbons mo, parehas na sila magkatapat. Okay? Eclipse, they are behind each other, directly. Hindi lang yung carbon yung nagbubungguan, even the hydrogens are on top of each other. And you know, atoms contain electrons, so magre-repel mga yan. So, of the three conformations, sino yung pinaka-stable? Again, the most stable conformation will be your anti. Anti siya kasi all the atoms are in the opposite direction. They are not overlapping. Ang lesser stable ay yung gauche, such as this one. So kapag gauche yung ating mga carbon groups, medyo nagtatamaan. And the most unstable conformation will be the eclipse. Eclipse meaning nasa likod ng isa't isa yung atoms. Okay? So this is the unstable conformation because may electrons yan. Magre-repel sila. Okay? So ganun lang. Okay? So again, so this is anti, gauche, and eclipse. Most unstable, eclipse, followed by the gauche, unstable yan. This one is also gauche, kasi nandun sila. And this one is anti. Okay? So, anti is yung stable, gauche is lesser stable, and the eclipse, that is the most unstable. Okay? So, bakit kailangan natin alamin to? So, we need to know this na kasi we will apply this concept in our cycloalkanes, specifically cyclobutane. So, let me just connect some of the atoms here to make cyclobutane. Magdugtong lang ako ng atoms. So, what is a cyclobutane? A cyclobutane is the cyclic form of your cyclopentane pala ito nasa picture. So yeah, so cyclopentane is a cycloalkane of pentane. So ibig sabihin, it should contain 5 carbons. Kapag dino-drawing natin yan, siguro you are thinking na flat yan. Okay? So you are thinking na flat siguro yan. But in reality, it is not flat. Okay? Now, let me demonstrate you why. Okay? So, ito yung ating cyclopentane. Okay? So, ayan yung cyclopentane and flat yan for now. But, keep in mind na if it is flat, then all the atoms will be on top of each other. magtatamaan sila, ito, magtatamaan sila. Kumbaga, lahat sila naka-eclipse. So, it is unstable. So, ibig sabihin, ano kailangan gawin ni cyclopentane? So, in order for the cyclopentane to be stable, it needs to bend a little bit. And apparently, if it bends this way, okay, if it bends that way, this results to the most stable conformation of the cyclopentane, which is called the envelope conformation. Okay, so originally flat yan. Kasasabi nga natin, pag flat yan, nag-eclipse lahat ng atoms, therefore it is unstable. So in order to minimize that, we need to bend the bonds. Okay, so by just bending the bond, we are able to come up with this conformation. This is the envelope conformation. So this is the envelope conformation. Ayun lang. So that's the envelope conformation. Let me go back to the PowerPoint para makita nyo kung ano itsura niya. Yan, okay? So that is the envelope conformation. That is the most stable conformation of our cyclopentane. Another thing to note is that if your cyclopentane conforms to this structure as shown here, para siyang dog, no? So if it looks like that, ito, if you measure the bond angles, they are approximately 109.5, which is the ideal bond angle for your sp3 hybridized carbon. So, kailangan nyo talaga mag-bend. It should not be flat. Okay? So, ito 109.5, 109.5, except for this one. Okay? So, 109.5. Okay? So, yun. Medyo 109.5 yung angle. So, hindi lang yan yung conformation ng ating cyclopentane. Meron din siyang tinatawag na half chair. And the best one is the envelope. So, ano yung itsura ng half chair? Okay, let me pause it. I'll pause the recording. The sharing. So, ito yung envelope, di ba? Yung isang carbon nakapataas, the rest flat. Ang half chair, ito naman siya. Okay? So, ito naman siya. Although it looks kind of, mas stable ata siya, no? Kung makapansin nyo. But apparently, according to data, this is not the most stable conformation of cyclopentane. Okay. So, the best pa rin is the envelope pa rin. Okay. So, it is the envelope because the bond angle is nearest to the ideal bond angle, which is 109.5. Okay. And now, let's proceed now. So the last one we have here will be the cyclohexane. So again, cyclohexane, from the word itself, hexane na cyclic. So you have 6 carbons connected together to form a ring. And gaya nga ng sabi ko kanina, okay, let me just pause the sharing again. So just as I said earlier, it is not flat. Kasi, di ba, when we draw our cyclohexane, ganito yung ginagawa niya, naka-flat. But again, just as I said, the atoms will be eclipsing each other. So this will be unstable. So what will happen? So since unstable ito kasi nag-eclipse yung ating mga electrons ng atom, they need to bend. Ayan. So they need to do some bend. Okay. So yan. Teka lang. So, wait lang. Ang hirap i-bend. Ayan. Ayan. So, they need to bend in such manner shown here. Okay? So, ganun lang. So, this is the most stable conformation of cyclohexane. Kanina, flat yan. So, again, bawal yung flat kasi may eclipse. Okay, nag-eclipse yung ating mga electrons. So, in order to remove that, tension, okay, kailangan magganito sila. Okay, wait lang. Ayan. So, this is what's called a chair conformation. Siguro nagtataka kayo, no? Paano siya naging chair? Paano siya naging chair? Although it is not kind of visible in our case. Let me show the PowerPoint again. So, ang reason bakit yan tinawag na chair conformation is, ayan, mukha siyang upuan. Lagyan ko ng tao para mas makita niyo. Okay, so ito yung chair conformation, nakaganon yung tao. So, parang ganon din dito, no? So, yung tao dyan nakaupo. Andun yung paa niya, chilling, sana all. Ayan. So, yan yung chair conformation natin. Nakahiga yung tao dyan. Okay? So, yan yung chair conformation, and apparently that is the best conformation for your cyclohexane. Again, for cyclopropane, that will be the envelope conformation, while for the cyclohexane, it will be the chair conformation. Okay? So, bakit siya naging ideal? Kasi, let me pause the sharing. Okay, so, look at this again. So, nakikita nyo that when your when your cyclohexane follows this conformation, ano nangyayari? They are all anti. Anti yung kanilang configuration. Yan, look. Naka-anti sila lahat. No? So, ito. Hindi siya nag-overlap with this atom sa likod. No? So, wala masyado nag-overlap, no? Wala masyado nag-overlap dito. So, that's why it is the best conformation. Okay? So, hindi lang naman ito yung conformation ng ating, ng cyclohexane. Not only the chair conformation, we also have this thing called the boat. So, boat, ganito itsura niya. Kind of similar with the cyclopentane, pero dalawa yung nakapataas. Okay. So, this is the boat conformation. This is unstable kasi magbubungguan yung dalawang hydrogen na to. Okay. We also have the twist conformation. So, this is the twist boat. Okay. So, this is not really stable because of the, yung strain dito sa band na to. Medyo pangit yung pagkakaband niya pag tinignan mo dito sa point of view ko. Okay? So, the ideal conformation for cyclohexane talaga will be the chair conformation shown here. Because, as you can see, the bond angles are all 109.5 degrees. And that's the ideal bond angle for a carbon that is sp3 hybridized. Diba? Okay? So, yun lang for now. Okay? Just remember that for cyclopentane, the best conformation will be the envelope, while for cyclohexane, the best conformation will be the chair. So, apparently, in the chair conformation, some of the hydrogens are pointing in the axial position, while some are pointing on the equatorial position. Okay? So, ito yun. So, some of the hydrogens are pointing up and down, yun yung axial, and some are pointing sideways or the equatorial. Okay? So, again, let me just pause the sharing. Ito yun. So, saan dito yung mga axial hydrogens? Ito yan, no? Up, 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 down, down, down. So, May tatlong up, may tatlong down, so that's overall 6 H-shell hydrogen. And asan yung equatorial? Ito, nasa equator. Okay. So yun. So those are the equatorial and the H-shell hydrogens. Okay. So yun. That is something that is unique with the chair conformation. They have those things na equatorial and H-shell CH bonds. Okay? So ngayon, what if we are going to substitute other atoms dun sa hydrogen? No? What if palitan natin yan ng iba? Okay? For example, methyl. Okay. So, instead na hydrogen yung nandito, methyl ilagay natin. So, when placing the methyl, it could either be on the axial position or the equatorial position. Okay? Kunwari, lalagyan mo yan ng methyl. Pwede naka-axial yan. Pwede naka-equatorial. Pag axial, taas or baba lang. Pag equatorial, naka-side, naka-angle siya. So, which of those will be more stable? Okay? Suppose you are going to add substituents. Should it be the axial or the equatorial? Ano yung mas stable doon? Sabi dito, the most stable conformation for our substituted cyclohexane, ibig sabihin ng substituted, yung hydrogen pinalitan mo ng ibang carbon, in our case methane, the best conformation will be the one that is in equatorial rather than the axial. Bakit kaya? Kasi in the axial position, mag-e-eclipse si CH3 with hydrogens na. They will eclipse with hydrogen. However, if it is in the equatorial, CH3 will not eclipse with these two. Ang tawag sa eclipsing effect when it is on the axial position, tawag doon ay 1,3 diaxial interaction. So again, this is the eclipsing effect when your substituent is in the axial position. And that will cause the molecule to be kind of unstable kasi axial eh. Nag-eclipse eh. So it is better if you place it on the equatorial position. Okay? So to further visualize it, now let's go back to our model. So this is our cyclohexane. So this is our cyclohexane. Suppose I'm going to change one of the hydrogens with the methyl. Okay, so palitan natin siya with methyl. Okay, so to further show you the 1,3 diaxial interaction. Okay, so yan. So this is the methyl cyclohexane. Ayan, so ito yung methyl na pinalitan ko yung hydrogen doon. As you can see, the bulky group na malaki, literal na malaki, the bulky group of the methyl will directly interact with these two hydrogens here. So yun yung 1,3 diaxial interaction. Bakit 1,3? So count ka dito, 1, 2, 3. On the third carbon, nandun yung hydrogen na mag-interact doon. 1, 2, 3. Pangatlong carbon, nandun yung hydrogen nag-interact dito. So that's why it's called 1,3 diaxial interaction. Okay? So this group of atoms will repel against each other. They will eclipse again. So that will be unstable. So the best way, if you want to place your substituent sa inyong cyclohexane, is to place it on an equatorial position. So if it is in equatorial, okay, so kapag siya ay naka-equatorial, it will not eclipse with any of the atoms. So hindi siya mag-eclipse with any of the atoms, making it more stable. Okay, compared to the eggshell ones. Okay, so what if you have two substituents? Okay, So what if you have two substituents? If you have two substituents, then you can have this thing called the cis and trans isomerism. Cis and trans isomerism, it came from the Latin word mga cis and trans. Cis, ibig sabihin same side. Trans, ibig sabihin opposite side. Okay? So basically, yun yung cis and trans isomerism. Okay? So let me illustrate it with you using, again, my models. I'm just switching colors. I'm sorry. Ayan. So let me demonstrate you the cis and trans isomerism in cyclohexane. Okay. So if your substituents are both pointing on the same direction, so yun, kung pare sila naka-up, pare sila naka-down, ibig sabihin nun, cis isomer yun. Cis meaning same side, no? However, if one is pointing upward and the other is pointing downwards, then you call it the trans isomer. Okay? So, ayan. So, looking at this one, we have two methyl groups, both pointing downwards. So, tawag natin dyan will be the cis. And yung isang methyl group nasa taas, isang methyl group nasa baba, tawag natin doon ay trans. Okay? So, to show you, again, using models, okay, so that's a cyclopentane. So, let me just remove carbon here. Okay, so this is the envelope conformation of our cyclopentane. So these two green are our new substituents. Na? So if they are both on the same side, yan ay cis, same side sila. Okay, magkatabi sila. However, when you place the other substituent on the opposite direction, yung isa is pointing upwards, the other is pointing downwards, such as this one, it's called the trans. Okay, naka-trans yan pag ganyan. Okay? So, yan yung cis and trans isomerism. One is pointing out upwards, the other is pointing downwards. Okay? We can show the upward and downward position of our substituents using these two type of wedges. We have the solid wedge and the dashed wedge. Okay? Pag sinabing solid wedge, ibig sabihin it is pointing upwards. Okay? So if this is the plane of your molecule, then pag may nakita kang ganitong bond na makapal, ibig sabihin nun, yun yung solid wedge. It means it is pointing above. While if you see a dashed wedge, okay, may naka-dash dyan, ibig sabihin yan, it is pointing downwards the plane of the molecule. So, kumbaga, if I draw this, ito yung flat na molecule, both of them will be pointing upwards. While for this one, if I draw it, ito yung flat na molecule, one will be pointing upwards and the other will be pointing downwards. Okay? So, that's the way of representing the spatial arrangement of your substituent. No? Pag nasa taas, siya ay solid. Kapag nasa baba, siya ay dashed. Okay? So again, to identify the cis and trans isomerism, just basically look if they are pointed on the same direction. If they are pointed on the same direction, that will be cis. Otherwise, if they are pointing on the opposite direction, ibig sabihin they are trans. Okay, so now let's talk about the physical properties of alkanes. So for the physical properties of alkanes, commonly the type of bonds that we can see in alkanes is a nonpolar bond, diba? So nonpolar yan. Meaning, it is just bound by dispersion forces. Okay, pag sinabing dispersion forces, ibig sabihin nun ay ano, the more carbons, the higher the dispersion forces, or the more atoms, the higher the dispersion forces will be. Okay? So, yun lang. So, yun yung ating uh, physical property of the alkane. Okay? So, also, one important thing to take note is that if you have a chain of alkane, if sila ay naka-straight lang, like the usual zigzag, they will have higher intermolecular forces than those of the branched alkanes. Ang branch alkanes, ito yung alkanes na may mga substituents. Okay? So again, it is important to know that yung alkane mo, kapag yan ay straight chain lang, ibig sabihin, iyan ay mas maganda yung intermolecular force nila compared to those with lesser um, straight chain. Yung less yung kanilang yung pagkakapatong na. So, kumbaga may substituents sila. So, if they have substituents, then lesser yung London dispersion forces nila. So, if lesser yung London dispersion forces, ibig sabihin, they tend to have lower boiling point. Okay? While those who are in straight chain will have higher boiling point and melting point. And that can be shown here. So this one is for the unbranched alkanes. Ibig sabihin, straight lang silang zigzag. As you can see, as the number of carbons increases, the molecular, the melting point also increases together with the boiling point. However, if you increase the branching, okay, pag ginawa mo substituent yung mga carbon, ang mangyayari is that yung inyong in yung London dispersion forces, it will not be at the optimum. Hindi siya magiging maximize. So, ibig sabihin, bababa yung kanyang intermolecular forces kapag may mga branches. So, looking here, so these are the 5 isomers of of C6H14. So, hexane, 3-methyl, 2-methyl, 2,3-dimethyl, and 2,2-dimethyl. So, habang dumadami yung branching, the boiling point decreases further. Okay? So, ganun mangyayari sa quiz, no? So, pag nakita nyo, eto, compare mo yan with the other molecule. Sino yung better? Is it the branch or the unbranched? So, sasagot mo doon will be the unbranched. Okay? So, yan. Kasi kapag unbranched, maximize yung London dispersion forces. While, if yan ay may branching, may mga substituent, hindi na ma-maximize yung dispersion forces. In terms of solubility, just as I said, hydrocarbons are composed of nonpolar bonds. So, meaning it is not soluble in water because of the non-polarity of the bond. Okay. So, however, if you have both alkanes, no, pwede mo sila pagsamahin. This is the concept of miscibility. Like dissolves like, no. Sabihin, if yan ay polar, it will dissolve polar. No? If it is non-polar, it will dissolve non-polar. Okay? So, apparently, ang ating alkanes, they are non-polar. So, ibig sabihin, they will only attract non-polar molecules as well. They will dissolve in non-polar molecules as well. Kaya kapag may gasolina na natapon sa sasakyan, nung bata ako na observe ko to parate. Pag may gasolina, di ba umuulan, tumutulo yung gasolina, nagiging kulay rainbow, tas may film doon ng gasolina. So, yan. Basically, the idea lang there is that hindi kasi mag-mix yung gasolina sa tubig. Kasi tubig is polar, while gasolina, which is hydrocarbon lang, is non-polar. So, yun. So, in terms of density, hydrocarbons are less dense. Okay? Less dense primarily due to their low molecular weight. Okay? So, technically, they float in water. Ayan. So, now, we are on the last part of the alkane discussion. So, the characteristic reactions of alkane are the following. So of course, we know that hydrocarbons can be used as the fuel in combustion reactions. No? So that's the first reaction of our alkane, combustion. So alam niyo na to, nung stoichiometry pa lang tayo. So you have your hydrocarbon as your fuel and oxygen gas as your oxidizer. When you react it, they will produce heat, and that heat can either be used to power up the engines or even in generating electricity. Okay? So yung mga natural gas facilities, yan, ganyan ginagawa nila. They were able to produce electricity by just combusting the uh, hydrocarbons. But again, so nangyayari na recently yung COP26 na climate ano yun? Nakalimutan ko yung meaning ng COP. O basta yung nag-uusap yung mga ating leaders sa buong mundo. Climate Change Conference. Bakit siya COP? Triple C siya. Anyway, so mga bakit siya COP? Anyway, so the COP is currently happening abroad. I think that's in UK. And one of the major issues that they discussed there is the global emission of carbon dioxide. Primarily, our source of energy relies on the combustion of hydrocarbons or sometimes coal. Okay? And both of them produces carbon dioxide, as we know, given the equation for combustion reactions. And that is an existential threat for all of us. Okay? Malaking threat sa tao yung CO2. Okay? Because in just the recent years, now I don't know if you were able to watch uh, their discussions. No, just in the few centuries, no, when we developed, no, nagkaroon tayo ng industrial revolution, ayun, dumami yung CO2 production natin. Okay? And until now, it is increasing. If we do not control the CO2 production, then probably, in our lifetime, we will experience much severe droughts. Okay? We will experience much severe droughts as well as more intensified typhoon. And actually, just right now, na-experience natin to. So, di ba kayo nagtataka? Kasi this November ngayon, pero ang init-init. So, that is just the physical manifestation that so yun, that is just the physical manifestation of CO2, no, harming us, no. So what are the ways in order to alleviate this disaster? So we can go for energy sources that do not produce CO2. Uh, One of which is nuclear. I am a I am an advocate of nuclear energy. Okay. Kasi nag-OJT ako sa PNRI, so I know some of the some of the nuclear concepts, so I can promote it talaga. Or we use renewable energies, no? Such as yung ating wind, sun, no? Basta let us not rely on those that will produce CO2 talaga, no? So hopefully, no, in our lifetime, there must be uh, a significant change in our lifestyle and the way companies produce electricity. Because otherwise, mamamatay tayo. So that is an existential threat to all of us talaga. Okay, so anyway, so that's one of the characteristic reaction of alkane. Dami kong sinabi. The next characteristic reaction of alkane is the halogenation reaction. So basically, in the halogenation reaction, your alkane will react with chlorine gas or any halogen, chlorine, bromine, okay? Fluorine, chlorine, okay? So sila yung mga nagre-react. So they substitute, no? So, ibig sabihin, for example, ito yung ating alkane. So, pag nag-substitute yan, ibig sabihin, mapapalitan niya ng halogen. Okay? So, kunwari, so from methane, ito yung methane, puro hydrogens lang nasa paligid niya. That methane, when you react it with chlorine, yung isang hydrogen, mapapalitan ng Cl atom. Together with it, HCl will be produced. So, nag-substitute lang talaga sila. Okay? So, yung Cl, pati H, pag sasamahin, ayun, and then yung Cl na natira, idugtong mo dito. So, CH3Cl. The thing with halogenation reaction is that it can proceed until all the hydrogens are substituted by the halogens. Ibig sabihin, it can continue further until a point wherein all the hydrogen are replaced by the halogen. Okay? So, kaya makikita mo dito, so after CH3Cl, pwede pa yung mag-react. So, after reacting, it will now be CH2Cl2. So, yung hydrogen dito, mapalitan na naman ng isa pang chlorine. And then after producing that, this can be produced, and finally, the CCl4. Okay? Or the carbon tetrafluoride. So, the reaction mechanism is complex. So, huwag nyo na ito kabisaduhin. I just pasted it here para makita nyo na complex talaga siya. But that's what's happening when you react your halogens with the methane. Okay. So, ano yung application nito? So, one of the application of our halogen substituted hydrocarbons is our chlorofluorocarbons, which are used before in refrigerations. No? Not only in the refrigeration, but also as aerosol component. No? So, yung mga hairspray dati, they contain chlorofluorocarbon. Yung ref, they contain chlorofluorocarbon. So, yung aircon nila dati, they also contain chlorofluorocarbon. Okay? So, it seemed na it is a revolutionary molecule. No? However, it came to a cost. Ano yung naging cost ng chlorofluorocarbon? The destruction of the ozone layer in 1970s. Okay? So until now, sira pa rin yung ozone layer natin. Okay? So apparently kasi, when we have our chlorofluorocarbons emitted into the atmosphere, kunwari may sira ka ng refrigerator, pag nasira yung refrigerator, usually ginagawa dyan sa scrap metal, yung gas sa loob ng compressor niyan, pinapasingaw lang sa hangin. So pag yan ay sumingaw, it will go to the atmosphere. Okay? So in the atmosphere, okay, there are tendencies that our chlorofluorocarbons will degrade the ozone. Okay? So it will degrade the ozone, meaning yung ozone magiging oxygen gas na lang. Is it a good thing? No. Okay. Kasi apparently, we know that ozone protects us from the harmful ultraviolet rays from the sun. So without the ozone layer, we are at more risk of being cancer patients in the future. No? So that's why when they discovered this phenomena, they eventually banned the use of chlorofluorocarbons and now opted to use much safer alternative. Okay? Yung aming refrigerator sa bahay, it does not use any chlorofluorocarbon anymore because it's 2021. Rather, they use hydrocarbon, pentane. Okay? So yun, pentane na lang yung ginamit nila, which is much safer than the chlorofluorocarbon. Kasi again, yung chlorofluorocarbon, it can destroy the ozone. Kaya may mga picture na ganito sa internet. Yan yung butas na ozone natin. So imagine if the use of chlorofluorocarbon still happens today, probably lahat tayo or most of us will have skin cancer. But with the help of good governance and policies by the UN and with the coordination of many nations, nahinto yung pag-increase ng ozone hole, no. So although it is stagnant right now, but at least it did not exceeded the limit na sinasabi nila. Okay, hindi na siya lumaki palalo. No? So yun, ibig sabihin yan, there might be a hope, no, that ano, we will be able to achieve our goals, no, to lessen the production of CO2. Pero it will really take some time, decades yan, before we can see the effect. And ano, um, yeah, medyo matagal nga siya. And hopefully, the international community will agree that it is really an existential threat. So, gaano pa man kayaman yung bansa or kahirap, lahat apektado. So, yeah, we really need to do something. For us, no, hindi naman tayo mga policy maker, but we are citizens of the country. What we can do for now is to, ano na lang, um, to reduce the CO2 emission, although compared to companies, mas onti lang naman yung CO2 emission natin. Pero ano lang, go for ano na lang din, some lifestyle changes. And in reality, it is not just the CO2 na problema natin. We also have concerns with the plastics, no? So lahat ng mga yan, they will eventually make us all extinct. So hopefully, before that happens, something was done na. No? Okay. So yun, so that will be the end of the alkanes, and I will upload the alkenes and alkynes on Thursday. Okay. So that will be all. See you next time. Bye bye.